So in the third unit, there is a thread in the distributed system. So in this, we will see what is the process. Process means any program is in execution, process control, block control, the operation of any process. Process control block contain information about process, for example, process priority, process ID, process state, CPU, register, etc. A process can create other process which are known as child process. Process takes more time to terminate and it is isolated, means it does not share memory with any other process. The process can have the following state like new, ready, running, waiting, terminated, suspended. If you see the thread is segment of processes, means a process can have multiple threads and these multiple threads are contained within a process. A threads have three states: running, ready, and blocked. Thread takes less time to terminate as compared to process, and like process, thread do not isolate. Process in OS can remain in any of the following states. Either in new, a new process is being created; ready, a process is ready and waiting to be allocated to a process; running, the program is being executed; and waiting, the waiting for some event to happen or occur, or otherwise it is terminated. So this is all about the process. How do process work? When we start executing the program, the processor begins to process it. It takes the following steps. Firstly, the program is loaded into the computer's memory in binary code after translation. A program requires memory and other OS resources to run it. The resource such that register, program counter, and a stack, and these resources are provided by the OS. A register can have an instruction, a storage address, or other data that is required by the processes. The program counter maintains the track of the program sequence. The stack has information on active subroutines of a computer programs. A program may have different instances of it, and each instances of running program is known as the individual processes. Feature of the process: each time we create a process, we need to make a separate system call for this, and the fork function create the process. Each process execute exists within its own address or memory space. Each process is independent and treated as an isolated process by the OS. Processes need IPC, inter-process communication, in order to communicate with each other. A proper synchronization between the processes is not required. So this is single thread process and the multi-thread process. So, so this is one single thread, data and file, code, data, file, register, stack, and counter. Right. So these are all multi-threads which supposed to be executed. It's a single thread supposed to be executed. So there's a registry of this particular thread, counter, and the stack. So register, register, register is the stack, will be a counter. So all three. How does thread work? As we have discussed that the thread is a sub-process or an execution unit within a process. A process can contain a single thread to multiple thread. A thread works as follow. When a process starts, OS assign the memory and resources to it. Each thread within a process shares the memory and resources of that process only. Threads are mainly used to improve the processing of an application. In reality, only a single thread is executed at a time. But due to fast context switching between the threads, gives an illusion that threads are running parallelly. If a single thread executes in a process, it is known as threaded, and if multiple threads executes simultaneously, then it is known as multi-threading. Single threaded and multi-threading. Types of threads. There are two types of threads which are user level thread. As the name suggests, the user level threads are only managed by the users and the kernel does not have its information. These are faster, easy to create and manage. The kernel takes all these threads as a single process and handles them as one process only. The user level threads are implemented by user level libraries, not by the system calls. And there is in kernel level threads. The kernel level threads are the second type of the threads are handled by the operating system and managed by its kernel. These threads are slower than the user's level thread because the context information is managed by the kernel. To create and implement a kernel level thread, we need to make a system call. A feature of the threads share data, memory, resources, files, etc. with their peer thread within the process. One system call is capable of creating more than one threads. Each thread has its own stack and register. Thread can directly communicate with each other as they share the same address space. Thread need to be synchronized in order to avoid unexpected scenarios. If you talk about process and thread, their differences, then you will see the clear idea about how it works. A process is an instance of a program that is being executed or processed. Now in thread is a segment of a process or lightweight process